Hello, welcome to linear inequalities in one variable and interval notation. This is for intermediate algebra. My name is Tuesday J. Johnson. I am an assistant professor at Doña Ana Community College and a lecturer at the University of Texas, El Paso. Intermediate algebra is Math 120 at DACC. This is Chapter 1 of Turner-McKeague's Equations and Inequalities in One Variable. That's not true. It's Chapter 2. Section 2.4, Linear Inequalities in One Variable and Interval Notation. The addition property for inequalities. For any algebraic expressions, a, b, and c, if a is less than b, then a plus c is still less than b plus c. In other words, adding the same quantity to both sides of an inequality will not change the solution set. Here's an example. Let's take, should be blue. If we have 7x plus 4 is less than 6x minus 17, I can choose to move the 4 to the right-hand side of the inequality by subtracting 4 from both sides. That one should have been in blue. And I'll end up with a minus 17 and a negative 4 on the right side. In the same step, I'm going to subtract 6x from both sides, because if I subtract 6x on the right, they will cancel out, whereas the 6x subtracted from 7x gives us a single x. So 7x minus 6x is x, my terms that canceled. My less than or equal to, it's strictly less than. I need to pay attention here. Minus 17 minus 4 gives me a negative 21. Some interval notation and graphing. We have set builder notation, and this looks somewhat familiar. X is less than 2, x is less than or equal to 2, and so on. But the set builder notation has these, what I call squiggly brackets. Squiggly brackets are all actually called braces. I just don't like to use that term. But the braces tell us we have a set. The x, this little line means such that x is less than 2. So this says literally the set of all x such that x is less than 2. We could write that in interval notation. X is less than 2 means all numbers that are almost 2 but smaller. And we always write our intervals from least to greatest, so it needs to look the same as it would on a number line. So negative infinity is smaller than 2, so negative infinity has to be to the left of 2 in our interval. I like to use the parentheses and brackets idea when it comes to graphing on a number line. The parentheses that we use here, because we have no equal to, so we use parentheses, is the same parentheses we would use here on 2. They face the same direction and everything. But if you're familiar with the solid dot, closed dot, solid dot, open dot, you can use that method as well. The set of all x such that x is less than or equal to 2 will now have the square bracket around the 2, because we can include 2. Whereas x is greater than or equal to negative 3 gives us the square bracket negative 3, comma infinity. And similarly for our graphs, the set of all x such that x is greater than negative 3, round bracket. So if it has the equal sign, it's a square bracket. A square bracket, if you look at the top and bottom itself, has a built-in equal sign. If you just ignore that little vertical line right there, that's how I remember that this means equal sign. The top little line and the bottom little line make an equal sign. So the inequality has to have an equal. And the interval has to have the same type of diagram, going in the same type of direction, the same bracket. Alright, so for our examples, we're going to write in set builder and interval notation, and then graph the solution set on a number line. Just a little bit of practice. For my classes, I give a handout on this also, just to get some practice in going back and forth. Given one, can you find the other 3? So, if x is less than or equal to negative 2, I know that's the set of all x, such that x is less than or equal to negative 2. Less than or equal to means we're going to go forever to the left. Maybe a number line would be an easier way of seeing that. Forever to the left. And the biggest it could be is negative 2. Because we have the or equal to, We'll have the square brackets around the -2 or the solid dot if you choose that method. You do not have to have both of these. Choose one, whichever one works better for you. For example number 2, x is greater than 0. That's the set of all x such that x is greater than 0, set builder notation. Greater than is going to go to the right, so that's from 0 to infinity. There's no equal sign, so we use parentheses. Infinity is a value we can never reach, so we always use parentheses around infinities. On a number line, 0, and it goes to the right because it's greater than. To the right for greater than, to the left for less than. If x is greater than or equal to 14/3, that's the set of all x, such that x is greater than or equal to 14/3. Close your set. Greater than means we're going to go to the right, so our diagram, our number line goes to the right. Our interval notation, square bracket, 14/3, comma, infinity, always round parentheses on infinities. If x is less than -7/6, that's the set of all x. That is not written correctly, is it? I need to model good behavior here. Strike through that. That's the set of all x such that x is less than -7/6. Your squiggly brackets might be ugly, like my one on the left, or they might be a little bit better looking, like my one on the right. It doesn't matter, as long as you get them in there. In interval notation, because it's a less than, forever to the left, so from -infinity to -7/6, my number line graph goes to the left, parentheses or an open dot at -7/6. I always put in a second number just to show order. It doesn't have to be very close to it. 14/3, I'd have to think really hard. What is that? I don't know, but 10's bigger. -7/6, I don't want to get all detailed. I know -100 is to the left of that. It doesn't matter how you label. Just show two values so you can show some sort of direction that you understand that a number line has smaller numbers to the left and larger numbers to the right. Multiplication property for inequalities comes in kind of two parts. Let A, B, and C represent algebraic expressions. Algebraic expressions. If A is less than B, then AC is less than BC if C is positive. Okay, what that says is, as long as you're multiplying by a positive value, the direction of the inequality stays the same. However, if A is less than B, then AC is greater than BC if C is negative. So we can multiply both sides of an inequality by a positive value or by a negative value. However, when we multiply both sides of an inequality by a negative number, it reverses the direction, the sense of the inequality, and that all comes down to our number line. Remember that on the right, our numbers go in a natural increasing order, but in the negative direction, the numbers that we think of as bigger, like 2 and 3, are actually smaller when they're negative. So switching the direction of inequality makes sense when you multiply by a negative because you've now flipped over to the other side of the number line. Example 1. We're going to solve minus 2x minus 5 less than or equal to 15. First step, use the addition property. We're going to add 5 to both sides, no big deal. We can add 5, things are still groovy. Less than or equal to negative 2x is less than or equal to 20. At this step, I am going to divide by a -2. And because I'm dividing by this negative, the direction of my inequality will change. If I multiply or divide in this last step, the direction of my inequality changes. So instead of less than or equal to, now that I've divided by a -2, I'll have x is greater than or equal to -10. Greater than or equal to goes to the right. That's a closed interval on -10, parenthesis, comma, infinity, close parentheses, and the number line graph that matches. Example 2, if we want to solve 9/5 is greater than -1/5 minus 1/2 x. First thing I'm going to do is I'm going to multiply by my least common denominator. I have 5's and I have a 2. So 10 is going to be my least common denominator, and 10's a positive number. 10's awesome. When I multiply by 10, the direction of the inequality remains the same. 10 times 9/5. 5 goes into 10 twice. 2 times 9 gives me 18. Greater than. 10 times a negative 1/5 is negative 2. Right? 5 goes into 10 twice. 2 times negative 1 is negative 2. Minus sign. 10 times 1/2 x. We know that half of 10 is 5. So this will be 5x. And now I've taken it back to a similar problem. We can add 2 to both sides. Adding or subtracting on both sides of an inequality, no big deal. And then I'll have negative 5x on the right, and I want to divide by a negative 5 in order to get my x by itself. But when I divide by a negative 5, it switches the direction of the inequality. Notice 20 divided by negative 5 is negative 4. Negative 5x divided by negative 5 is x. Because I divided by a negative, I switched the direction of the inequality. But this negative 4 is less than x kind of hurts my head. I like to know about x first, and then I compare it to a number. So since the inequality is opening towards the x, I could rewrite this as x is greater than negative 4. So as long as I keep the pointing at the negative 4 open towards the x, I can rewrite the order because x is greater than negative 4 is also negative 4 to infinity and gives me my number line. It's a little easier to wrap your head around. 3/4 x minus 2 is greater than 7. It doesn't matter if everything is a fraction or only one term has a fraction. I'm still going to multiply by the common denominator in order to simplify. But I don't just multiply the term that has the fraction. If I choose to multiply 3/4 x times something, I must also multiply the 2 and the 7. I have to multiply every single thing in the entire inequality. So 4 times 3/4 x minus 4 times 2 is greater than 4 times 7. Multiplying 4 times 3/4 x, the 4's cancel, and I'm left with 3x. Minus 8 is greater than 4 times 7 is 28. To solve, I'm going to add 8 to both sides. 3x greater than 36. To get x by itself, I'm going to divide by 3. I divided by a positive, so it's all good. X is greater than 12. In interval notation, make a comma right there. If x is greater than 12, and the number line graph showing us from 12 on up, 12 comma infinity, both with parentheses because there's no equal sign. Last example, 3 times the quantity 2y minus 4 is greater than or equal to 0. First we distribute, get rid of our grouping symbols. 3 times 2y is 6y. 3 times a negative 4 is negative 12. 6y minus 12 is greater than or equal to 0. Now we solve, we use the addition first. We're going to add 12 to both sides of the inequality. Adding or subtracting on both sides, no problem. Everything stays the same. 6y is greater than or equal to 12. Divide by 6, it's a positive value, so when I divide by 6, it's all good. I end up with y is greater than or equal to 2. Greater than or equal to tells me it's forever to the right, so a bracket on 2, extending to infinity, close with parentheses, an interval notation, and a number line graph, brackets on 2, facing to the right, because my graph goes to infinity. Notice the two values that I listed here. The 0 wasn't even included in where my number line was going. It doesn't matter. As long as I have two values to show direction on my number line, it's good to go.